Assalamualaikum. Today we're going to talk about light and optics for physics form 4. Today's subtopic is image formation by spherical mirror, and this will be the last topic for form 4, for physics form 4. Okay, so my name is Cikgu Suryati Yusof from Sekolah Menengah Sains Muzaffar Shah Melaka. Okay, so we are going to look at the image formation by spherical mirror. Okay, so this is all the application that we will learn just after this. Okay, so we begin with so this picture. So when we look into a mirror, we can see our image in the mirror. The image seen in the mirror looks exactly the same. How does the image in the mirror form? So mirror is function due to the reflection of light. So we are going to talk about part of the reflection of light by using mirror, and specifically we will use spherical mirror. Okay, reflection of the curved mirror. Okay, there are two types of curved mirror. Okay, one is called concave mirror, another one is convex mirror. So concave mirror is this is concave mirror, this is the convex mirror. Okay, so concave mirror called inwards. Okay, so this convex dia inward, right? And this will become outwards. Okay, alright, this is how we get. So we have a spoon. So the spoon, a metal spoon, a shiny metal spoon, can act as a mirror. So this is the concave surface. So this is our eyes we see from here, and convex we see from this position. Okay, so concave surface and convex surface of a steel spoon act as a concave mirror and convex mirror respectively. So this is the image for see in the concave surface. Looks like inverted, and convex surface, it seems upright, okay, and smaller size. Okay, can you state the characteristic of the image formed by concave surface and convex surface of the spoon? Okay, we are going to study this characteristic. Okay, this is example of the image seen from the concave mirror. The image is upright and big, right? Okay, this is a concave mirror. At this position, you see that the image is inverted and quite small size or diminished. So image inverted and small. This is a convex mirror. Image always small and upright. So this is in the supermarket, seen on the corner of the road. Okay, image is upright and small. Okay. Convex mirror also is used for the side mirror of a car. So this is the side mirror of the car. This is a convex mirror. So the image is very small. Okay. Now we begin with activity 1. Image formed by convex mirror and concave mirror. Okay, so we have two mirrors, concave and mirror. We put on a piece of white paper and we shine a ray box to produce parallel ray directed at the mirror. So draw the ray diagram with the step using a convex mirror. Okay, this is what you should see. So what happens when parallel rays are directed toward the two types of mirror? For concave mirror, the parallel rays is converged at the focal point after reflection. So this is what you see, the parallel light, okay, and reflected at one point. So all reflected and meet at this point. Okay, this is what we call focal point. While convex mirror is all the parallel is reflected and diverged as it comes from a focal point behind the mirror, something like this. So this is the convex mirror. So the parallel rays are being reflected as it comes from here, from a point here at the back of the mirror. Okay, so we go very detailed. Okay, principle exists. So this is what we call pole of the mirror. Okay, so all the parallel rays will converge and focus at one point. That is what we call focal point. So parallel reflected and converge at the focal point. Okay, so this is a concave mirror. Now how about convex mirror? So principle exists, pole of the mirror. So diverge as it come from here. Okay, point here. same thing. So this is what we call focal point. So diverge, reflected and diverge is come from a focal point behind the mirror. This is what we call behind the mirror. Okay, so now we compare between the two mirror. So concave mirror converge all the parallel lines, and for convex mirror it will diverge as it come from here, right? Okay, so actually how we produce spherical mirror. So we have a hollow glass sphere. So this is the center of the curvature. So this is the point P. Okay, so we cut the part of the hollow glass and we leave this part only. So now we coated the outer surface. So coated here. So this is the object. So this is the what we call this is the concave mirror. Okay, so surface that reflect light, and here is the convex mirror. They coated inside. So this is the object here. So this is the part that is reflect the light. So this is convex mirror, this is concave mirror. Okay, now we move on to the terms regarding the curved mirror. Okay, first, principal axis, the line which passes through the center of curvature and the pole of the you're straight here. Normally it will be the divide the mirror into two parts. Okay, focal point, a point through which all rays traveling parallel converge after reflection. So a point where all parallel light will converge after reflection. Focal point, pole of the mirror. So this is the pole of mirror. Middle point on the curved mirror is the convex or concave mirror. Focal length is the distance between the focal point and the pole of the mirror. Radius of curvature is the distance between C and also pole of the mirror. Okay, so F will be the half of the radius of curvature. Center of curvature means center of the concave or convex mirror here, and the distance is equivalent to 2F. So here to here is F, another one here to here is F, so you have 2F. Okay, and object distance of object from the pole of the mirror. So this is the object, so distance from the object to the pole of the mirror. Image distance, distance of the image from the pole of the mirror. Okay, alright, so construction rules for concave mirror and convex mirror. Okay, so we have a white paper, we have a concave mirror put on the white paper. So now this time we have only one light, so three rays. Okay, three separate rays, right? One array parallel to the principal axis, another one array passing through the point F, another one array passing through point C. So repeat with convex mirror. So this is what you will see. Okay, so this is a parallel, will reflect through F. Another one, so this is the experiment that we can do just. Okay, so it's parallel reflected to F, right? Now secondly, a ray passing through F is reflected parallel to the principal axis. So this is opposite. So parallel going to the focal point will reflected parallel. Okay, so it's like in this picture. Okay. Pass through F, goes to the mirror, and then will reflected straight. Okay. And thirdly, we have C, the light coming, so it will pass reflected back along the same path. Okay, so reflected back along the same path. Okay, I have a video here to show you. Okay, the experiment. Okay, straight goes to F. Okay, parallel goes to F, and then we have pass through F going to be parallel, and thirdly straight pass through C and we will reflect it back in the same path. Okay, now we move on for convex mirror. Okay, three rules for convex mirror. A ray parallel to the principal axis is reflected as it comes from F. Okay, a ray directed to F is reflected parallel to the principal axis. Okay, and a ray is directed towards C is reflected back along the same path. Okay, like this. Okay, now the rules to find the image. So we have rule number 1, parallel, refracted to F. Again, passing through F is refracted parallel, and passing through C will reflected the same path to the intersection of the 3 lines will give you the position of the image. Okay, so now the image is inverted, which is real and a smaller size. Okay, this is the setup experiment to study the image formation on the through the spherical mirror. So this is the object. I use a candlelight, easier. This is the object. Here is the mirror, concave mirror, and here is the screen. So that the object, the light from the object, the candlelight will go through the concave mirror, and then will be reflected, goes to the screen. Okay, example of experiment. So this is the image formed on the screen. Very clear, it's inverted. Okay, so this is the subject, and here is the mirror. The light from the candlelight goes to the mirror, goes to the screen, and the image is formed here. Okay, here's another example experiment. So this is candlelight, here is the mirror, and here is the screen. Okay, so this is the image formation formed on the screen. So very clear image. So it's inverted. Okay, this is another mirror. This is inverted. This is upright. Okay. Yeah, we have 2 different type of image here. So this upright, smaller. Yang ni apa? Upright also. Okay, it means that with the same mirror for the concave mirror, we can have a different characteristic of image. It depends on the object distance. Okay. So this is a concave mirror. So at one point you have a inverted, at one point you have it a big size and upright. But convex mirror, we always get what we call smaller image, upright and smaller image. Okay. So now our task is to draw a ray diagram without doing any experiment. Okay. So how to draw for the 5 distance? So we start with U larger than 2F or U bigger than C. So this is the object. So now this is FC. The object is U larger than C. So we have 2 lines here. Go straight, goes to F, pass to F, and go straight. So the intersection will give you the location of the image. So the image is inverted. So inverted, it should be real, inverted and diminished. So it should be real, inverted and diminished. Okay. So F, V is the location of the image in between F and also to F. Now we move on to the next one. U equals to F or U equals to C here. Okay, so we move forward from U larger than 2F just now. So what you get is straight line goes to F, parallel go to F. Passing through F will become parallel back, and here is the location of the image, and nicely is situated on also U equals to 2F, and the image is same size, inverted and real. So real, inverted and same size, and object or image is at V equals to 2F or equals to C. Okay, now we move forward so that U is between F and 2F. U is between F and 2F. So we draw the first line, parallel goes to F, F parallel. Okay, so this is the location of the image. So the image is upright. Sorry, the image is inverted. When inverted, it must be real, and the size is magnified. So it should be real, inverted, and magnified. Okay. Now last step, the next step is you move forward so that U equals to F. So what we see here is straight line, parallel goes to F. Okay, this time we have to have C here. We cannot have F, so we use C passing to the object and passing to the lens. Sorry, to the mirror. So it's something like that, and it looks like it is in parallel. So the image is at infinity. Okay, virtual, upright, and magnified, and the image is at infinity. So this is for U equals to F. And the last part is for the concave mirror, U less than F. So this is U less than F. What you do is we draw the line, goes to F. So another one is from C, goes to the object, goes to the mirror, like this, and we extrapolate backward. So this is the location of the image, right? So virtual, upright, and magnified. Boom. Okay, now we conclude with the table. Okay, U larger than 2F, real inverted diminish. U equals to F, real inverted same side or raise. U in between F and 2F is real inverted magnified or rim. U equals to F, virtual, upright, magnified, and the image is at infinity. And lastly, U less than F, virtual, upright, magnified, or boom. Okay. Now, we go further. State the position to get real image and virtual image. Okay, real image must be U larger than 2F, U in between F and 2F, U equals to F. For virtual image, U must be equals to F or U must be less than F. State relationship between the object distance U and image distance, so they will become inversely proportional. Okay, and then state relationship between the object distance U and the size of the image. So the size of image, when the V is longer, size of image is smaller. Okay, sorry, size of image is bigger. So size of image follow the image distance. Okay, so it will be inversely proportional. Okay, now for convex mirror, so we draw what we call principal axis. So this is F. Now I add up with 2F or C here. Okay, so this is the object. So straight line, parallel, diverge as it comes from F here. So now we draw a line here, and we will travel in the same path, back in the same path. So where is the location of the image? So this is the location of the image. So the image is smaller, upright, and virtual. Okay. So upright, virtual, and smaller. Okay, this is the example of use of the convex mirror. Is the mirror at the top of the shop in the lot, right? Okay, now we move on to the next application, makeup mirror. What is the type? So the makeup mirror, so it looks like you look at through the mirror and the image is bigger, right? So what is the type of mirror used? So this is concave mirror. State the position of the observer U less than F, because we want the characteristic virtual, upright, and magnified. We want it upright and magnified. Okay, so when upright, it must be virtual. So concave mirror is used to create a magnified and upright image of the space. Okay, this is another example where you use plane mirror, concave mirror. So this is a plane mirror, small. It's not small, it's the same size as your face, and here is bigger size. Okay, virtual, upright, same size, virtual, upright, and magnified. For makeup, the lady must be close to the concave mirror. That is U less than F. Okay, now we move on to the transmission of radio wave and signal. So we cannot run from this through this. So near the shape of the reflector, concave mirror, where is the location of the signal receiver? So it should be at the focal point, where U equals to F. Gain reason. So the incident wave from the satellite or from the distant object are parallel and will focus at focal point after reflection. So this is the point of focal point. Okay, now we move on to the torchlight, reflector of torchlight. So inside the torchlight there is a reflector, a shiny reflector. So then the type of reflector used is concave mirror. Where is the location of the light bright? Again, is at the focal point of the reflector. How does the reflector function? So light from the bulb at F, okay, here, hit the reflector and will reflect parallel. Remember, when parallel, when the light from the focal point will be reflected and will be parallel. Reflect parallel and can see distant object ahead. Okay, so this is example. So this is the high beam, this is the low beam. Okay, right. So this is the, can see distant object when high beam. Okay, when the bulb is at the focal point. This is, can see shorter distance because the light is coming like this, right, downward. Okay, bulb F light reflected parallel to see distant object in front. Okay, so this is low beam, this is high beam. Okay, dentist mirror. Need the type of mirror used, it should be concave mirror. State the position of the tip from the mirror. It should be used U less than F. State the characteristic, it should be virtual, upright and magnified. So this is the mirror. Okay, car side mirror. Okay, name the type of mirror used for the car's rear view and side mirror. Should be convex mirror. State the benefit, because we want to wider view of vision. Driver can see object at the back and at the side of the car to avoid blind spot. So this is for normal field of vision. This is for concave mirror. This is for the convex mirror. See that? Wider field of vision. Okay, mirror at the sharp corner. This is the type of mirror. Again, this is a convex mirror. Explain. Light from the car ahead. So light from the car ahead is reflected by the mirror to the driver. And you can see an upright a small image, wider view of vision. Okay. It's more safe for safety purpose. The image produced by convex mirror always virtual, smaller and upright. Can see the whole shop. Okay, like this. Okay. Okay, now if we compare convex and concave mirror, so here we see image in convex mirror are always smaller. Here we see image in concave mirror are always bigger. Right. Okay, thank you. So I hope you understand. See you later. Assalamualaikum and goodbye.